All right, we're doing 6.2, inverse functions and relations. The first objective that I have to have you do is you have to be able to determine whether two functions are relations. Now, we can, of course, look at a graph and decide are they reflections over y equals x. But we learned some useful things yesterday with compositions that will help me decide if they are functions or not without even having to look at a graph. Yesterday we learned about the composition of functions. We learned that we can take one function and put it in for x into the other function. In other words, we can do f of g of x, where we take the g of x equation and we put it in for x into the f equation. Just as a reminder, g of x is x minus 6. So I'm going to put x minus 6 in for x. So I have x minus 6 plus 6, which is just x. Now this is good. This is what we want. If you do the composition of two functions and your answer is just x, that means there's a real big possibility that they're inverses of each other. To solidify that, we have to do the composition the other way. So we're going to find g of f of x. And in that, we're going to take f of x and put it in for x into the g equation. So that means we're going to take x plus 6, because that's what f of x is. We're going to put it in for x into the g equation. So I have x plus 6 minus 6. And that equals x. Since I got x for both of these, that means that yes, they are inverses. If you get anything else at any time during either one of those compositions besides x for an answer, they're not inverses of each other. In fact, as soon as you complete one of the compositions, if your answer isn't x, you can stop right there and say, no, they're not inverses. Let's take a look at the next one. We're going to take the g of x equation and we're going to plug it in to f. So we have 1/2 2x minus 4/3. That's the g of x equation. Plus 3/4. 1/2 times 2x, that's x. 1/2 times negative 4/3, negative 4/6. Now you can do this by hand by doing the common denominator, or you can stick it into your calculator and do negative 4/6 plus 3/4 and change it back to a fraction, you get 1/12. So as simplified as this can go is x plus 1/12. Answer wasn't just x. So they're not inverses. That also means since the first composition was an x, I don't even have to do the second composition. But if you work it out and the first composition is x, then you have to do the other way. It doesn't matter which one you start with. Yes? On a quiz, you only have to say yes or no, because the directions just say write yes or no. Let's take a look at C. So we are going to take g of x, and we're going to put it in to f. We're going to pretend that that said f all along. So I'm going to take 2x cubed, and I'm going to plug it in for x. Well, by golly, I can't go any further. And that's not x. So the answer is just no for both of those. Which means I don't even have to do the second composition. I don't care if I get x. Let's take a look at our second objective. The second objective is that you can find the inverse of a relation. So that means a set of ordered pairs. This is probably going to be your favorite kind of problem throughout the entire chapter because it's by far the easiest one. All you have to do is switch x and y. So when I go to find the inverse of this first relation, I'm going to take and switch each one of these coordinates, x and y. So I have 3, 0, 2, 4, negative 6, 5. Told you this one would be your favorite. The next one, negative 2, 8, 5, 10, 6, 12, 7, 14. That one had a little extra hump in it. Turn it over. Our final objective for 6.2 is I can find the inverse of a function. There's a lot that kind of goes into this part, or a lot of different pieces that we're going to talk about in this objective. The first one is this idea of the horizontal line test. Now, we learned way back in chapter 0 that the horizontal or the vertical line test can be used to tell whether or not the graph I'm looking at is a function. The horizontal line test is used to be able to tell whether or not the inverse of the graph I'm looking at is a function. So the horizontal line test goes like this. When a horizontal line is drawn on the graph of a function, if the horizontal line only ever intersects at one point on the graph, then the inverse graph will be a function. If the horizontal line intersects more than one point on the function, then the inverse will not be a function. Let's practice this just a little bit. So skip down to the bottom. Part of the directions for number 2 ask you to graph the function. So let's go ahead and graph the function on each of these. Now, of course, as always, you are allowed to use your calculator and find a table and plot the points there. Or since this one is just a linear equation, the slope is 0, the y-intercept is negative 3, so I'm going to go down to 0, and I'm going to go down 3, right 1. And I can go the opposite way, up 3, left 1, and then draw my line. Taking a look at the second one, the slope is 4, the y-intercept is negative 6, so I'm going to go down 6, up 4, over 1. and draw my line. And the last one, you can plot it by hand, or you can always go to your calculator and type it in. And get some points from there. And let's put this horizontal line test in action. Now first, we're going to use the vertical line test to see if all of these are functions. So remember, the vertical line test says I can drag a vertical line across. If it only touches once, that graph's a function. So is this one a function? Yep. Is this one a function? Yep. And the last one, it's also a function. So the horizontal line test then tests whether or not the inverse of each of these graphs is a function. So the first one, it passes the horizontal line test. It only touches one place. So the inverse is a function. Take a look at the next one, horizontal line test. It passes, so the inverse is a function. Take a look at the last one. This does not pass the horizontal line test. It touches the horizontal line in two places. So the inverse is not a function. Now the directions for number 2 ask us to find the inverse of each function, then graph the function and its inverse. So far, we've just satisfied one part of this. We graphed the function. And in order to actually find what the inverse of this function is, we're going to go back and kind of use some of what we used when we were finding the inverse of a relation. To find the inverse of a relation like we did on the other page, the first thing we did, well, the only thing we did, was switch x and y. And there's just one more step when you're trying to actually find the inverse of an equation or a function. And that step is to solve for y. Keep in mind, guys, that when you see an f of x, that's going to be your y. So let's apply that for each of these functions below. First step, switch x and y. So this becomes x equals negative 3y. Next, solve for y. So I have to divide by negative 3. So I get y equals, remember there's like a 1 in front here, so negative 1/3 x. For the next one, to find the inverse, switch x and y. X equals 4y minus 6. And solve for solve for y. So add 6 to both sides. Divide by 4. So I have 1/4 x plus 3/2. The final one, switch x and y. X equals y squared minus 3. Add 3 to both sides. Then square root both sides. So when you square root both sides, remember a plus or minus goes in the front. That's not necessarily the case if it was, well, it's not the case if it's an odd root. So if you're taking the cubed root of both sides, you don't have to put a plus or minus in front. So let's go back and actually graph each one of these. Because we found the inverse of each of the functions. We've graphed the original function. Now we have to graph its inverse. So the y-intercept here is 0. And the slope was negative 1/3, so down 1 over 1, 2, 3. Up 1 over 1, 2, 3. Graphing the next one, the y-intercept is 3/2 or 1.5. Up 1 over 1, 2, 3, 4. Down 1 over 1, 2, 3, 4. The last one, we can go about it a couple of different ways. Really, we could have gone about it a couple of different ways for all of them. But remember, we determined that this one was not a function. Its inverse was not a function. And your calculators are set to only graph in function form. There's other forms that you can use later on, but in this class, we only graph in function form. And this is not a function. So option number 1 is to trick the calculator into graphing it anyway, meaning we're going to separate this out into 2 parts. So we have the square root of x plus 3 And we have negative square root of x plus 3 because we had a plus or minus in front. So that's two easy parts to split it into. And of course, you can go to your table and plot it. So that's one way. Go through, plot all your points. The other way is to use your knowledge of what you know about finding the inverse of a relation. So this particular point is at 0, negative 3. The inverse of that would be, switch x and y, negative 3, 0. This point is at negative 1, negative 2. So the inverse of that would be negative 2, negative 1. And do that for each one of the points, and you'll get your inverse graph. Either way, calculator, use your table, switch each of these. It doesn't really matter to me. So this one's at negative 2, 1. So 1, negative 2 would be a point. 1, negative 2 is a point. So negative 2, 1 is a point. And the last one, 2, 1 is a point. So 1, 2 is a point.